Hello friends, dear learners and my dear student. First of all, I take an opportunity to welcome you at my TYBSc Analytical Chemistry class. Friends, I am Dr. S.R. LABHADE, working as Associate Professor in Chemistry at KTHM College, Nasik. Student, in previous lecture we discussed the technique of paper chromatography. Under this we discussed what is stationary phase in paper chromatography, what is mobile phase in paper chromatography, how paper chromatography work. In addition to this, we discuss qualitative and quantitative analysis by means of paper chromatography. Student, in today's lecture we discuss the technique of a thin layer chromatography. Thin layer chromatography, as the name suggests, a thin layer of adsorbent material is given on the glass plate or a plastic plate, and that acts as a stationary phase in this chromatography. Therefore, it is called as thin layer chromatography. Basically, thin layer chromatography is a adsorption type of chromatography. Definitely, stationary phase is solid adsorbent. In case of thin layer chromatography, mobile phase is a liquid and sometimes a mixture of liquid or a liquid containing buffer solution. Now we discuss how this thin layer chromatography works. Basically, thin layer chromatography is an adsorption type of chromatography in which stationary phase is solid adsorbent having specific functional groups, and mobile phase is liquid having capacity to dissolve the sample component present in the mixture. Therefore, here a sample containing different component when loaded or applied to the one end of this adsorbent material, mobile phase dissolves the sample component and carries them through the stationary phase. When these sample components come in contact with the stationary phase having specific functional group forms a bonding, that means hydrogen type of bond is formed between the solid molecule and adsorbent material. And a stationary phase tries to hold this molecule on its surface by forming such a bonding. If stationary phase have a capacity to hold that particular molecule strongly, means that molecule have a more capacity to form a hydrogen type of bond with the stationary phase. Therefore, solid which have a capacity to form more bonding with the stationary phase, that will be strongly adsorbed on the stationary phase. That means it will be moves with a slower rate. In contrast to this, sample component having capacity to form a few bond or no bond with the stationary phase, that migrates with a faster rate or that migrates with the mobile phase. Therefore, here how much bonding is formed by solid molecule with the stationary phase, on the basis of this, the sample components are get separated. If sample component is more polar molecule forms a more strong bond with the stationary phase, and therefore that will be strongly held than the non-polar or less polar compound. Therefore, thin layer chromatography particularly useful for separation of a polar and non-polar molecules. Here, thin layer chromatography is an adsorption type of chromatography in which sample components are separated on the basis of relative adsorption towards the stationary phase. Students, now we discuss how this thin layer chromatography is performed. Thin layer chromatography is performed by using all these steps. Number one is selection of glass plate and a stationary phase. Second one, selection of mobile phase. Third one is preparation of sample solution. Next is loading of sample solution or application of sample solution. Next is saturation of tank, development of chromoplate, then detection of separated spot by physical and chemical method, and qualitative analysis, and after that we can apply this thin layer chromatography for specific purposes. Here we can discuss each step sequentially. Number one is selection of glass plate. In case of thin layer chromatography, it is an adsorption type of chromatography in which solid adsorbent material is coated on the glass plate or plastic plate. Sometimes aluminum plate may be used. Therefore, here glass plate, aluminum plate or plastic plate is used as a support for a stationary phase used in thin layer chromatography. Generally, in laboratory condition, a glass slide having dimension about length about 5 to 10 centimeter in length, then width is about 2 to 2.5 centimeter. Such a glass plate is selected as a support for the stationary phase. Second step is a selection of a stationary phase. Stationary phase in thin layer chromatography is a solid adsorbent. This solid adsorbent that is in a powder form, and this powder form solid adsorbent may be silica gel, alumina, sometimes magnesium silicate, or cellulose powder can be used as a material for a stationary phase. Therefore, here it is an adsorption type of chromatography, and therefore this material acts as a solid adsorbent material. These adsorbent material have a specific functional role. Last time we discussed if there is silica gel having such a type of bonding, that is OH. Here in this case we know that this will be delta positive, delta negative, delta negative, delta positive. In addition to this, there is lone pair of electron on this oxygen. Therefore, these are the active sites present in the silica gel when it is used as a stationary phase in thin layer chromatography or in a chromatography. In case of chromatography, a material having such active sites, only that material is used as an adsorbent material or as a stationary phase. Any material that cannot be used as a stationary phase in chromatography, stationary phase in chromatography have a specific functional roles, and then only that stationary phase involved in separation process. Here silica gel having structure like this, and that is most commonly used as an adsorbent material in chromatography. In addition to this, alumina, that is Al2O3, magnesium silicate or cellulose powder may be used as a stationary phase in thin layer chromatography. Generally, silica gel is preferred for separation of more polar compounds. If compounds are more polar, then generally to separate polar compound from one another, here silica gel is preferred. Weakly polar or less polar compound, those can be separated by using a alumina. Therefore, here again choice of stationary phase will be depends upon the type of sample to be separated. If compounds are more polar, then generally a silica gel is used as a stationary phase, or weakly polar compounds that can be separated by using a alumina. Now in this case, next step is a selection of the mobile phase for a thin layer chromatography. Again, mobile phase means a developing solvent. Mobile phase that may be a pure organic solvent, sometime 2 or 3 organic solvent in a proper proportion, sometime organic solvent plus buffer solution, such a type of mobile phase may be used. Selection of mobile phase is again depends upon the type of solute to be separated. Here condition is that the sample component must be soluble in developing solvent, then and then only those will be carried by the mobile phase through the stationary phase. Otherwise, if sample is insoluble in developing solvent, then mobile phase unable to transport them through the stationary phase and separation is not possible. Therefore, in case of chromatography, mobile phase must have ability to dissolve all the sample component, and then only those sample components are carried through the stationary phase. Function of mobile phase is to carry the sample component through the stationary phase in any chromatographic method, and therefore here that will be carried by the mobile phase when sample components are soluble in mobile phase. Therefore, depending upon the solubility, the mobile phase is selected in order to enhance the solubility of sample component. Mixture or buffer solution may be used. Next is preparation of a chromoplate. That is not written here. Preparation of chromoplate. Chromoplate means here on this glass plate we have to give a thin layer of the adsorbent material, and when a thin layer of adsorbent material is given on this plate, then it is called as chromoplate. Now, how chromoplate is prepared? For preparation or application of stationary phase on the surface of this glass plate, initially we have to prepare the slurry of this adsorbent material. Any one adsorbent material is selected. In this case, slurry of adsorbent material is prepared into the volatile solvent. Generally, a chloroform or acetone, such a type of solvent or low boiling point liquids are used for preparation of slurry. During preparation of slurry, sometimes small amount of calcium sulfate may be added as a binder. That means here it holds this stationary phase on the glass surface or plastic plate. Therefore, binder may be a calcium sulfate, but calcium sulfate is used very small amount. Therefore, here stationary phase is dissolved into that low boiling point liquid. A slurry of that adsorbent material is prepared, and by dipping this glass plate into that slurry, a thin layer of this adsorbent material having thickness around 0.1 to 0.3 millimeter. Therefore, this much thickness of that stationary phase is given uniformly on this glass plate, and that will be act as a stationary phase in thin layer chromatography. Thickness of adsorbent material should not be more than this, otherwise development is not possible. This is because of here longitudinal migration is also possible along with this axis, and therefore here to avoid this a longitudinal diffusion, the thickness of the adsorbent material is not more than 0.5 millimeter, and therefore here for good development the adsorbent material or its thickness should be as small as possible. Once we coat the adsorbent material on this glass plate, next we have to dry this glass plate in a oven or sometime under IR lamp. Here drying is carried out to remove the residual solvent. Because here slurry of adsorbent material is prepared into the volatile solvent, no doubt that get lost, but sometimes some solvent may be linked with these active sites, and therefore if solvent is present or it is linked with this active site, here there is no development because these active sites are get blocked by the solvent molecule. Therefore, to active these active sites or bounding sites on the plate, we have to dry that plate in order to remove the residual solvent. That is called as activation of chromoplate. Once we load this, once we coat the thin layer of that adsorbent material, then we have to activate the glass plate by heating it up to temperature 110 degrees centigrade. To this temperature, whatever the solvent including water that is lost, and then this chromoplate becomes active. Next step is a preparation of sample solution. Similar to paper chromatography, sample solution in thin layer chromatography is prepared into suitable volatile solvent, or sometimes a developing solvent may be used. If volatile solvent is not available, then developing solvent may be used for dissolution of sample. But sample generally dissolve into volatile solvent because we have to apply that sample onto the glass plate containing the stationary phase. Therefore, after preparation of sample solution by means of fine capillary, we have to load the sample on this glass plate containing stationary phase in the form of spot. Here care should be taken that no baseline should be drawn on this glass plate. When we draw the baseline on this glass plate, the adsorbent material will be removed from that plate, and here the development, there is error in the development. Therefore, to avoid this, here a glass plate, there is only imaginary baseline on this glass plate. A sample is loaded on the glass plate in the form of spot, and here the area of this spot is about 2 to 3 millimeter. And here dimension should be less than this or equal to this, and this spot containing about 10 to 100 microgram of solid. Therefore, this spot having area about 2 to 3 millimeter, and here that have a capacity or that contain about 10 to 100 microgram of solid. Now after application of sample, again we have to dry this plate, because whatever the solvent present in this sample solution, that we have to lose. Otherwise here that sample, that active site present in the sample also blocked by that solvent, and therefore again after loading the sample, the activation is carried out. Once we load the sample, next step is before that we have to carry out the saturation of tank. Saturation of tank is simply we have to add the mobile phase into the jar, and mouth of the jar should be closed. This step is carried out 10 to 15 minutes before the development of the chromoplate, because in this case fumes of that volatile solvents are get saturated in the open atmosphere of the chamber, and here loss of solvent molecule can be avoided because of saturation of tank. Once we saturate the tank, after that we have to develop this chromoplate. Therefore, for development we have to place this chromoplate into this jar containing this mobile phase. This mobile phase means it is a organic solvent or mixture of organic solvent. Again, similar to paper chromatography, here the sample loaded baseline should not be dipped into the mobile phase or developing solvent. The sample should be about to developing solvent, and this solvent migrates in upward direction by capillary action, and this is a ascending development is carried out in case of thin layer chromatography. In case of thin layer chromatography, no descending development is carried out. In thin layer chromatography, only ascending development is carried out. When this solvent moves in upward direction, it dissolves the sample component and carries them on the glass plate or on this stationary phase in this fashion. And here, when the solvent reaches about 7 to 8 centimeter from the baseline, then we can say that the development is finished or chromoplate is developed. After that, after development of chromoplate, we have to remove this chromoplate. Immediately we have to mark the position of solvent front. Then after marking the position of solvent front, we have to dry the plate. Care should be taken that during drying, no part of this adsorbent material should be falls down from the plate, because here that contain separated material on that adsorbent material or on that glass plate. After that, we have to detect the spot. We have to locate the position of separated spot on the glass plate. This is done by means of physical and chemical method. In physical method, simply we have to observe that glass plate under UV lamp so that if fluorescent material is present, that fluorescent material shows the fluorescence and we can locate the position of that fluorescent material by observing that plate under UV lamp. If fluorescent material is absent, then chemical methods are used. In chemical methods, we can use sometimes mean hydrogen for detection of amino acids, sometimes selective reagent for detection of particular inorganic metal ions like paper chromatography. Therefore, here specific reagent or sometimes specific compounds are used for detection of a spot. Yesterday we are using mean hydrogen as a reagent for detection of amino acid. Here we also use mean hydrogen for detection of amino acid. Sometimes if organic compounds are present and if those are colorless, then its reaction with iodine is carried out. Therefore, we have to place this plate in iodine chamber and we have to mark the position of the separated spot by using a iodine chamber. Sometimes concentrated sulfuric acid and methanol, this mixture may be used as an oxidizing mixture for detection of many organic compounds. Therefore, chemical reaction is carried out for detection of compounds and physical method means simply we have to observe that plate under UV lamp. Once we locate the position of spot on the glass plate, next step is determination of RF value. RF value, similar to paper chromatography, RF value is a ratio of distance travelled by solid from the baseline to distance travelled by solvent from the baseline. RF value is a retardation force or retardation factor, which is the identity of material utilized for identification, which is the identity of material useful for detection of which type of material is present. RF value governed by type of stationary phase present or type of stationary phase used and type of mobile phase used for separation purpose. But under identical experimental condition, no two compounds have the same RF value and therefore RF value is a physical constant that we can use for identification of particular compound. Therefore, similar to paper chromatography, qualitative analysis is done in thin layer chromatography. After this, we have to discuss the applications of thin layer chromatography. Compared to paper chromatography, thin layer chromatography is a faster method or faster technique of chromatography because it takes only 10 to 15 minutes for development. And here, a reproducible results are obtained in case of thin layer chromatography. And therefore, most of the time, the thin layer chromatography is used for, number one, detection of poisonous material or drug in the body fluid. It is also used for detection of sugar in a urine sample. In addition to this, thin layer chromatography is useful for determination of purity of organic compound by recording their RF value. Therefore, here this is a very simple and fast technique for detection of purity, that means whether that compound or that product is formed or not, that is detected by means of thin layer chromatography. These are some important applications of thin layer chromatography. In addition to this, thin layer chromatography can be used by biochemists, then botanists for separation of chlorophylls, polypeptides, phenyls and all organic compounds that can be separated by means of thin layer chromatography or identified by thin layer chromatography. Student, this is about the technique of thin layer chromatography and its application. Based on today's discussion, you can find out the answers of following question. Number one, what is TLC? TLC means it is a thin layer chromatography, but It is a adsorption type of chromatography in which solid adsorbent material is coated on the glass plate or plastic plate. Then what is the analytical principle or separation principle involved in thin layer chromatography? Number third, how thin layer chromatography is performed in a laboratory and what are the different applications of thin layer chromatography. In addition to this, you must know what is RF value and what is its analytical significance. RF value, that is retardation force or retardation factor, and which is the identity of material which is useful for identification of a particular substance. All these are the applications of thin layer chromatography. Student, in forthcoming lecture we discuss the gas chromatography, that is a special technique of chromatography useful for identification and estimation of gaseous and volatile samples. With this, we stop here. Thanks for joining me. Keep learning. Happy learning.